Hello, my name is Alex Hung, and I'm the guy sitting on the left side of the classroom usually. And today I'm going to present the current state of nanomedicine in modern healthcare. Let's take a closer look, featuring Nano Technology. Well, the term nanotechnology was first used in 1974. At that time, the concept was still foreign to most scientists in the medical field. However, over the past 30 years, nanotechnology has evolved to become a vital part of modern healthcare. Concrete inventions have resulted from this research, such as the scanning tunnel microscope and the structure fullerene, which is composed of carbon atoms. The prefix nano is actually defined as 1/1000th of a measurement. In terms of numbers, that's 0.000000001. That's a lot of zeros. Whoops. Nanomedicine is the medical application of nanotechnology. So it ranges from molecular nanotechnologies, medical nanomaterials, and finally nanoelectronic biosensors, which is a topic which I wrote my essay upon. So how does nanomedicine differ from conventional processes? Well, nanomedicine is much more effective, it's cheaper, it's somewhat automated, there's a lower toxicity in the human body due to its higher compatibility, and it's more related to organic chemistry, and it's very specific to certain diseases, which makes it more efficient, and it focuses on prevention rather than trying to treat already infected individuals, which requires very expensive health specialists. So how's it related to the Ask a Lawyer presentation given at the U of T, presented in the U of T? So nanotechnology is a leading future of modern healthcare in sensing disease biomarkers. As presented by Shanna Kelly, the professor of chemistry and pharmacy director at the University of Toronto, the goals with these electronic nanosensors, which she presented about, are supposed to be highly accurate, highly sensitive, have a low cost, multiplexed, have a low power consumption. They're supposed to be automated in terms of sample processing, and they're supposed to have a small footprint in the human body. So here's an example of one of these self-powered wireless nanosensors. So here's the nano generator, which collects photons, but with these very sensitive solar panels, which can collect sunlight from inside the body, which powers the capacitor, and ultimately the sensor and transmitter, which is the whole point of these nanosensors. And the sensor and transmitter would transmit back the data to the doctors inside the human body. And then here's like a little tree diagram of how the processes would work. Microfluidic devices are basically how scientists would deal with the results which they receive from these nanosensors. And you can see they place them on these little circles, on these little, I don't know what they're called, we'll just call them plates for now, and then these plates would be analyzed by the machines, and then the scientists would know what to do with the results. In summary, the chip, which has been developed by Shanna Kelly, has a low cost of fabrication, which makes it useful for patient screening. So in a real-world application, it could be used for, say, example, an epidemic or an outbreak of a disease, and there's a bunch of people who want to check if they're infected or not, and then this kind of technology would be very useful and very efficient in trying to figure out who has the disease or not. And right now, the automated version or automated part is still under development. However, it'd be much more efficient for the chips to automatically analyze the data which they receive. So moving on. In terms of our curriculum, nanomedicine has a strong correlation with organic chemistry and the structures and properties of matter. Well, the first one's kind of obvious because organic chemistry is the study of matter involving carbon atoms, and nanotechnology is based basically upon the structures of carbon atoms. Organic bioelectronics, such as the organic conducting polymers have higher compatibility, they have a low cost, and easier manufacture since they're basically grown. These carbon structures in organic chemistry are found in things like carbon nanotubes and graphene, which is kind of like an armor reinforcement used in things like armored vehicles or soldiers' bulletproof vests. So why carbon? In particular, carbon has extraordinary thermal conductivity and mechanical and electrical properties. They find their applications as additives in very structural materials. For instance, they're found in real-world materials or objects such as in baseball bats, golf clubs, or car parts. Also because of their unique symmetry and electronic structure of graphene, the structure of a nanotube strongly affects its electrical properties. Which brings us to our next point. Structures and properties of matter are very important when discussing nanotechnology. Synthesizing the materials required for nanotechnology requires a good understanding of the structures and properties of matter. Carbon's properties are greatly affected by its structure when creating different nanotechnologies. The structure of matter is most important when dealing with materials such as, once again, nanotubes, computer monitors, and supercapacitors. This is particularly important because these devices, or parts of devices, are used in nanosensors, which is the main application of nanotechnologies currently in determining whether individuals are infected, or used in nanobots, which can help treat diseases at a molecular level. So the importance of understanding the structures and properties of molecules allows scientists to create specific carbon structures for targeting diseases specifically. They allow fabrication to be much more efficient, and they give a better understanding of how a certain molecule will behave. Because if a scientist can understand how molecules behave, they can have a better, they can develop these nanobots more efficiently, especially in terms of organic ones, because organic nanobots aren't actually mechanical devices. They're just compounds which have react with the human body in a certain way. Whoops. So in summary, in order to synthesize the vital inventions in nanomedicine, a strong understanding of the structures and properties of organic compounds are required. It is through these innovative nanomedicine inventions that doctors and other healthcare specialists will be able to tackle diseases directly at the source of infection and treat them with unprecedented efficiency. I hope you liked my presentation, and if you listened, props to you, man. So this was my presentation on the current state of nanomedicine in modern healthcare. I hope you enjoyed. Cheers.